true projects. In this video, we are going to explain about a project titled Effective Heart Disease Prediction Using Hybrid Machine Learning Techniques. Cardiovascular disease is a prominent cause of death worldwide, making accurate prediction a critical challenge in healthcare data analysis. Machine learning has emerged as a powerful tool in dealing with large healthcare datasets and aiding the decision making. It has also shown immense potential in Internet of Things applications. While previous studies have explored the ML-based heart disease prediction, our research takes a novel approach. We focus on identifying the essential features through ML techniques to improve the accuracy of cardiovascular disease prediction. Our prediction model explores the diverse feature combination and utilizes the well-established classification technique aiming to enhance the effectiveness of disease prediction and contribute to better health outcomes. The detecting heart disease is a challenging task due to multiple risk factors such as diabetes, high blood pressure, high cholesterol, and abnormal pulse rate. To tackle this complexity, data mining and neural network techniques have been employed to assess the heart disease severity. Given the potential for heart complications or premature death, accurate prediction methods are of utmost importance. This project introduced an innovative approach that leverages the machine learning technique to enhance the heart disease prediction accuracy. The method combines various classification algorithms like k-nearest neighbor, decision tree, SVM, voting classifier, and naive Bayes to predict the patient's condition based on the features like left bundle branch block and right bundle branch block. Additionally, the project highlights the advancement in the machine learning, showcasing its versatility in diverse applications. These are the basic requirements that are needed to build this project. The software requirement: Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements: operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB and hard disk of minimum 250 GB. To know the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, essential Python libraries are imported, such as Pandas for data handling, NumPy for numerical operations, Seaborn for data visualization, and sklearn for machine learning algorithms. These libraries provide powerful tool to support various functionalities throughout the project. And the second one is exploring the dataset. The dataset containing the heart disease related information is explored. This step involves gaining the insight into the data, checking for missing value, understanding the distribution of each attribute, and identifying any patterns or trends. Exploratory data analysis helps in understanding the data characteristic and aids in making the informed decision during the data pre-processing and the model building. The third one is data visualization. It applies to present dataset characteristics visually. This step helps in understanding the relationship between the different features, identifying the outliers, and visualizing the distribution of the target variables. Visualization like scatter plot, histogram, box plot, and heat maps are commonly used to gain the valuable insights. And the fourth one is data cleaning. It involves handling the missing value, removing the duplicate, and dealing with any inconsistencies or errors in the dataset. Missing values be filled with appropriate imputation technique, duplicates be removed, and outliers be treated or removed to ensure the data quality and the consistency. And the fifth one is putting the data to the train and test. The dataset is divided into the two subsets, the training set and the testing set. The training set is used to train the machine learning model, enabling them to learn the pattern and the relationship in the data. The test set is kept separate and is used to evaluate the model's performance on unseen data, providing an estimation of its accuracy on the real-world scenario. And the sixth one is building the model. Several machine learning algorithms are employed. The first one is random forest. Random forest is an ensemble learning technique that combines the multiple decision tree to improve the prediction accuracy and handle the overfitting. Easy decision tree is trained on a random subset of the data, and the final prediction is obtained by aggregating the prediction of all individual trees. This method reduces the risk of overfitting and provides the more robust and accurate predictions, making it well suitable for the complex classification task. And the second one is decision tree. It is a tree-based classification algorithm that makes decision based on the series of rules. It recursively partitions the data into the subsets based on the most informative features, creating a tree-like structure where each internal node represents a decision based on a specific feature and each leaf node represents a class label. Decision trees are interpretable and can handle both categorical and numerical data, making them easy to understand and implement. The third one is Naive-Bayes. Is a probabilistic classification algorithm based on the Bayes theorem and the assumption of the feature independence. It calculates the probability of a data point belonging to the particular class based on the probability of its feature given to that class. Despite its naive assumption of the feature independence, Naive-Bayes often performs surprisingly well in various classification tasks, especially with the high-dimensional data. And the fourth one is SVM, stands for Support Vector Mission. Is a powerful classification algorithm that finds the optimal hyperplane to separate the classes in the data. It aims to maximize the margin between the data points of the different classes, which leads to the better generalization and robustness. SVM can handle both the linear and the non-linear data by using the different kernel functions, making it suitable for a wide range of classification problems. And the fifth one is KNN. KNN stands for K nearest neighbor, is a simple and effective classification algorithm that assigns a data point to the class of its K nearest neighbor based on the distance matrix. It does not make any assumptions about the underlying data distribution and can handle the multi-class classification task. However, its performance suffers in high-dimensional data and it can be sensitive to the choice of the number of neighbors within it. And the last one is voting classifier. It is an ensemble method that combines the prediction of multiple individual classifiers using the voting called hard or soft. It aggregates the prediction from the different classifiers to make the final prediction, often leading to the improved overall performance and reducing the risk of individual model bias. Voting classifier is a versatile approach that can combine the diverse algorithm to leverage their strength and improve the overall prediction accuracy. And the seventh step is training the model. The machine learning model are trained on the training set where they learn from the input features and the corresponding target labels to make accurate prediction. And the eighth one is user give the input. A user-friendly interface is created to allow the user to the input data that are relevant to heart disease prediction. The interface prompts user to provide the details about the health status and other risk factors. And the ninth one is the given input is pre-processed for prediction. The user's input data is pre-processed in the same manner as of the training data. This step may involve encoding the categorical variables, scaling the numerical features, and ensuring the data is compatible with the trained model. And the 10th one is trained model is used for prediction. The pre-processed user input is fed into the trained machine learning model where each model predicts the likelihood of the heart disease based on the provided input data. And the 11th one and the final one is a final outcome is displayed. The prediction from all models are collected and the final outcome is displayed to the user. This outcome provides the valuable insight for the user to understand the risk of heart disease based on the input feature. The user can take the necessary actions or consult a healthcare professional for the further evaluation and the advice. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the various files within it. The static folder containing of the various folders like of CSS, JavaScript, assets and vendor within it. And the templates folder containing of the HTML documents within it as of home, index, notebook, results, sign-in and sign-up pages. And the app is an py file contains the information related to the front-end logic. It includes the code that is written in Python that handle the server-side operations such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the feeds is the dataset that we used in this project, and the model.pkl file is an file that contains the algorithm information and is loaded at the time of execution of the project for performing the certain operations like predicting the new data. And the notebook is an IP_NB file which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cells, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And to execute the project, we build a Flask framework as of web interface and total code that present of code, graph and output all in one place at of IP_NB file. And to execute the project, first we need to copy this address of the code folder and then open the Anaconda prompt. And then first change the location of this path as of F because the code folder is present in the app disk, and then write a command of cd space, paste this address of the code folder and then click on enter button. By this, the directory will change to that of the code folder's path, and then write a command python space app.py and then click on it. Here this command will execute the Python script and showing any of the syntax and logical issues in it. By this, the app.py file using this, well, the framework will host the application locally at this address, and we need to copy this address and paste it on any of the web browser, and I prefer to use of Google Chrome, and copying this local link and then click on enter button. Here we can see that the title of the project is of effective hard disease prediction using the hybrid machine learning technique with of sign in and sign up buttons. Click on the sign up button. Here it redirected to the registration page having the necessary details to be filled to create an account, but my account is already generated, that's why I'm using the sign in button, and it's redirected to the sign in page, and we need to enter the username and password as of admin and then enter. Click on submit button. Here it redirected to this index page containing of temperature, humidity, pulse and ECG within it. And then enter the details of temperature as of 23 and humidity of 12 and pulse of 14 and ECG of 84, and then click on submit button. Here the page is redirected and said that you are safe, and use this try again button to redirect to this index page and re-enter the details based on our person. And here I am entering the temperature as 35 and humidity of 45 and pulse of 95 and ECG of 130, and then click on submit button. Here the page is redirected and it shows as we have a chance of heart disease. In this way, we can predict the heart disease by using the hybrid machine learning techniques. And in conclusion, our project has achieved the significant progress in improving the heart disease prediction accuracy by applying the various algorithms like random forest, decision tree, naive-bayes, SVM, KNN and voting classifier. We have created a robust and comprehensive predictive model. This hybrid machine learning approach harnesses the strength of each algorithm, resulting in precise and consistent prediction. The tool offers available support for medical practitioners in early detection and proactive management of heart disease, potentially saving the life and improving the patient outcomes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.